Welcome to the module 3.3. In this module, we are going to discuss on the topics lung volumes, capacity, and lung compliances. In the previous two modules, we have discussed on the structure and functions of the respiratory system, the organs that forms the respiratory system, and the mechanism of breathing. My dear students, I want you all to quickly recollect the supportive systems that helps in the mechanism of breathing which we had discussed in the previous module, because the chest wall, the lungs, and the supportive muscles are instrumental in the process of ventilation of our system, which we keep on talking. In this module, we will confine our discussion mostly with the volumes and the capacities of the lungs. This particular picture is showing us a person taking up his pulmonary functions test. The person nose is clipped, so he has to breathe in through his oral cavity. By doing this, he is going to breathe through a device called the spirometer. This helps in understanding the disease condition of the lungs of the person by measuring the volumes and the capacities. This picture is very common to us now. We are known to this picture now because this is typically showing us how the chest wall, the lungs, and the diaphragm are moving during the cycles of inspiration and expiration, which we have discussed extensively in the previous modules. So, here the point to consider is how this lungs and chest walls are stretching and recoiling back. So there is some interesting property of the muscles of lungs which we have to keep in mind during understanding this concept. Right away, let us talk about what lung volumes are. As mentioned, when we want to understand the disease condition of our lungs, a person has to take through lung function test. LFT is to assess the severity of the disease. We will discuss more on this in our coming videos. Here, let us talk about the lung volumes. So, to list their lung volumes, let us go one after the other. To mention, the first volume is called as the tidal volume, which is denoted as TV in this picture. It is called as tidal volume. The next volume of interest is IRV, which is showing at the upper peak, the biggest peak in this particular picture above the black line is called as IRV. It is nothing but inspiratory reserve volume. The next volume is expiratory reserve volume. If you see, a peak in the downward direction is nothing but the expiratory reserve volume. It is denoted as ERV. There is one particular volume of unexplored interest is your residual volume, or which is called as RV. We will discuss each of these volumes in detail in our discussion. So there is one more volume which is measured, is called as the forced expiratory volume. It is represented as FEV1, which are measured in our spirometers, which we will discuss later. Maximum ventilatory volume is called as MVV, which is the maximum capacity of ventilation that can happen in a person. The capacities are inspiratory capacity, functional residual capacity, vital capacity, and total lung capacities. We will see each of these volumes and capacities in detail. To begin with, let us talk about the tidal volume or TV. If we look at the TV, it is a very harmonious wave. So it is nothing but tidal volume. What is a tide? Tide is one
cycles of waves coming in and out towards and outwards of the shore. So likewise, this tidal volume is the volume of air that is going to enter and leave the lungs during normal resting breathing. And the normal value for an healthy adult is about 500 ml. The next volume is IRV. It is nothing but inspiratory reserve volume. If we look into the inspiratory phase, the top end of the TV, the subject makes a maximum effort in drawing in of air by inspiration. It is called as the maximum inspiratory effort a person's lung makes is called as IRV, and the normal value for a healthy young adult is about 2000 to 3000 ml. The next volume is ERV. It is expiratory reserve volume. So by now we all may guess that this is just the inverse of IRV, and all our guesses are right. Yes, ERV, it is called as the expiratory reserve volume, and it is the maximum effort above the tidal volume a person's lung makes in forcefully exhaling the air is called as ERV. It is also called as the hardest expiratory effort a lung can make, and this normal value for this particular volume is 1000 ml. RV, it is the residual volume, and this particular volume, as the name itself says, residual volume. Residue means that remains or retained. So this volume is retained and remains within the lungs, and they are not going to actively participate in either of the cycles of inspiration or expiration, and this particular volume remains in the lungs to enable the lungs to be open without collapsing to support the mechanism of ventilation. So far we have seen four important volumes of lungs. It is tidal volume, inspiratory reserve volume, expiratory reserve volume, and residual volume. The residual volume is about 1500 ml, a normal value for an healthy adult, and this RV cannot be measured by the spirometry method. Here we have to use another method called as helium dilution technique, which we will discuss when we are trying to study the PFT in our next videos. Now we shall see the lung capacities. The term capacity, it includes more than one volume. So if we look into this graph, we shall see some grouping of volumes in the right hand side. To begin with, the inspiratory capacity, the expiratory capacity, and like that. Vital capacity is the volume of air that is breathed out by the most forcible expiratory effort after a maximum inspiration. So if we see here in this volume, vital capacity is summation of inspiratory capacity plus expiratory reserve volume. What is inspiratory capacity? It is a summation of tidal volume plus inspiratory reserve volume. So we know the tidal volume is the volume at resting condition, and inspiratory reserve volume is the forceful inspiration, and expiratory reserve volume is the forced expiration. So vital capacity is the maximum extent to which the lung can expand and contract in order to accommodate air. So this vital capacity is about 3.5 to 4.5 liters in normal is the normal value, but this value will go low. VC value will go low for aged persons, when we are in lying down in the lying posture, and for pregnancies this VC value will go down. On the other hand, VC value will go down in disease conditions like emphysema, pleural effusion, and congenital heart failures. So On the other hand, VC will be high for athletes and sports persons. So this VC is one of a important parameter that helps in understanding the lungs vital capacity. Then do you remember me telling FEV1, which is nothing but the timed vital capacity? So this is also one indication to understand the disease stages of emphysema. Here timed vital capacity is measured like in 1 second. In the first second of your expiration, a normal healthy lung can expel out of 70% of the air. The rest of the 30% can be exhaled out during the second and the third seconds. What is it for an emphysema condition? So when the disease condition is there and it is progressing, and this FEV1 value will go down. That is, if the value is below 60%, that is, if the at the initiation of the expiration in the first second, if the lungs is able to send only 60% or less, then that condition is abnormality. The next capacity is the functional residual capacity, and we look at the graph. It is the summation of RV plus ERV. RV is what? It is the residual volume and it is not participating in any of the cycles of respiration, and ERV is nothing but the excess of air that a lung can hold after the completion of an tidal volume, and this ERV value is some 1000 ml, and this is called as the functional residual capacity. The next capacity is called as the MVV. It is also called as maximum breathing capacity. It is nothing but the volume of air that can be breathed out by giving maximum effort in voluntary hyperventilation in 1 minute. That is, in given 1 minute, what is the capacity that a lung can forcibly exhale the air out of the lungs is MVV, and for disease conditions this MVV will vary. So normal value, it is always greater than 100 liters per minute, and so the next capacity is the TLC. It is nothing but total lung capacity. If we look at the image, it is the summation of the entire capacity of our lungs. It is summation of inspiratory reserve volume IRV plus tidal volume TV and functional residual capacity FRC. It cannot be measured directly by a spirometer, and the normal value of TLC is about 6 liters. There is always a ratio called RV by TLC. RV is what? Residual volume, and TLC is what? Total lung capacity. And about 25% of the TLC is accounted by the RV or the residual volume. That is, RV by TLC is normally 0.25. But in disease conditions like fibrosis and emphysema, this value becomes greater, and it is disproportionately increasing in conditions like fibrosis.
We come to an end to the discussion of lung volumes and capacities. Next, we will see what lung compliance is. In general, to comply means to yield.
Lung compliance is a measure of the lung's ability to stretch and expand. It is also known as the stretchability or distensibility. In other words, compliance is defined as the change in volume that occurs per unit change in the pressure of the system. Pulmonary compliance is the total compliance of both the lungs. It is a measure of the extent of lungs expanding for each unit increase in transpulmonary pressure. Here again, I will recollect what transpulmonary pressure is. It is the pressure gradient between the inside alveolar pressure and outside pleural pressure. It means it measures the force of lung elasticity at each point of respiration. Factors that determines the compliance of lungs are factors within the lungs and factors of the chest walls. So what are the factors within the lungs that determines compliance? It is the elasticity of the lungs, volume of the lungs and the phases of respiration, degree of congestion in the pulmonary capillary. So these are all the factors that are going to determine the lung compliance of a person, because various conditions like disturbances in the lungs, disease conditions of the lungs will influence this elasticity, volume of the lungs, congestion and chest wall movements. So let us see one after the other factors now. So elasticity, it is also called as the elastic recoil of the lungs. It means the ability of the lungs to retain its original length. We all have used a rubber band, which we commonly use to tie up some bags or something, some packages. So the rubber band, when we put a force to stretch it, it gets stretched and expands. When we release the rubber band, it gets back to its original length. It is due to the property of elasticity. The same way our lungs, when it is stretched, it expands, and when the air moves out, it recoils back to its original length. And this property of lungs to get back to its original length after a maximum stretch is achieved is contributed by the elastic fibers that forms the muscles of the lungs, and this is called as the elastance, or it means the elastic power of the lungs, and this depends upon the nature of the elastic fiber and the surface tension within the lungs. Surface tension. So this is a very interesting factor of alveolus, and it is nothing but an inner side of the alveolus is lined by a very thin monomolecular layer of fluid. This fluid makes a coating within the alveolus and it exerts some surface tension and it prevents the collapsing of the lungs when air is not there, or during the various cycles of the respiration, air move in and out. Due to this, there is pressure differences, volume differences, which should not cause the collapsing of the alveolus, and it is prevented by the surfactant that is present in the lining of your alveolus. The next factor is that contributed by the chest wall. Earlier we were discussing about lungs, which has the elastic property. So when pressure is removed, lung recoils back to its original length, but it is just opposite to that of the chest wall, where the chest wall, it has the tendency to expand. The resultant of these two opposing forces, because chest wall and lungs and the lining are a single unit which is working on the lung compliance, and if we see here, both the layers forms a different property. The thoracic cage has the tendency to expand and lung wall has the tendency to recoil back. So they are creating an opposing force at that particular junction, and this is contributing to the factors of compliance or the entire respiratory system or pulmonary compliance. This, in clinical medicine, The pressure volume loop is compliance of the respiratory system in the human being. If we look into the given graph here, we can see red color response, yellow color response and blue color response. The red color response is the compliance of the chest wall. The blue is the compliance of the lungs and yellow is the compliance of the respiratory system altogether. So, when we look at the red graph, it shows that there is a steep response. So, the compliance is high. The compliance is what? It is the change in volume to the change in pressure. For if the x-axis is pressure and y-axis is the volume. So, for the red graph, that is the graph for the chest wall, for a small change in the pressure, there is great change in volume, which means what? The chest wall expands to even a small change in the pressure. So, the compliance is high, and if we look at the compliance of our lungs, even here there is a small slight flat graph. So, for a small change in the pressure, there is an increase in the volume, but this volume changes is reduced as the pressure increases because of the elastic property of the lungs. So, in between them is the lung compliance or the combined respiratory compliance. So, the chest wall compliance minus the lung compliance is the total lung compliance. This lung compliance will be influenced when a person's lung has some disturbances caused due to the disease conditions that can affect the lung volumes, capacities and compliance. The next thing which we have to look here is the lung compliance pressure volume loop. If we look into the graph, it is showing an hysteresis loop, and this loop is formed for the inspiration and the expiration cycles of the respiration. So, if we look the lower curve, it shows a greater effort or more pressure is applied for small changes in the volume. That means what? During inspiration, the lung has to put more work to draw in more volume of air. So, for a unit change in pressure, there is very little change in the volume. Whereas, in the other hand, during expiration, for the same unit in pressure difference, there is a large volume of air is expelled. It means what? It is a spontaneous process. Expiration is a spontaneous process where a very less amount of work is done by the respiratory system to execute this process of expiration. So, if we see the difference is called as the airway resistance. It is the airway resistance that is caused by the conduction zone. If we look at the diameter of the airway from starting from trachea to down to the terminal end of the alveoli duct, the diameter of the conducting zone is getting narrowed as we move down the tracheal tree. The cross-sectional area of the trachea and large bronchi is comparatively less when compared to the total cross-sectional area of the fine bronchioles and the alveoli, because alveoli and their corresponding bronchioles are million in number. If we put together, the cross-sectional area of the bronchioli and alveoli are very much greater than that of the cross-sectional area of trachea and the large bronchi. Hence, the maximum resistance to the airflow, it occurs in this region, trachea and large bronchi. And when a person has bronchospasm, the airway resistance increases, and it is especially the resistance increases during expiration, because the lungs exerts a traction force on the walls of the tracheobronchial tubes, making them to dilate, and this is not going to happen during expiration, and thus in disease conditions like asthma, the which is characterized by bronchospasm, there is a particularly difficulty is experienced during expiration. This is also expressed in emphysema to certain extent. With this, I conclude the discussions of Module 3.3, the lung volumes, capacities, and compliances. And I want you all to go back and have an understanding on what are all the lung diseases and disturbances that contributes to these parameters. Thank you.